In this first part, I'm going to look at the idea of using Python functions as data, almost the same as using integers or floats or strings. To start this off, again, a lot of programmers, when they work in Python, they're used to the idea of manipulating things like numbers and text strings. You make variables that have those values, you make lists that have numbers and strings and so forth in them. But this same idea actually applies to the functions that you write. Like if I were to write a function greeting name, print hello name, for instance. Here's a function, hello Guido, for instance. That function itself is actually an object. I can pass it around. I can store it in variables, for instance. Like I could say G is equal to greeting. And now G becomes another name for that function. If I wanted to, I could take, like I have this items list, I could append greeting onto the end of the list, assuming that I spell it right, which I didn't there. Okay, so you could take that function, put it on the end of a list. If I did that, then the second item of that list is that function. I could say things like items to Guido. Turns out that there's not anything really special about a function. It's just an object like anything else. I mean, you can put it in lists, you can put it in dictionaries, you can pass it around, and so forth. Now, it turns out that this is actually a very useful thing to know about in Python because one of the things that happens quite a bit is that people will write code that takes functions as input. And just as an example of that, I'm going to write a little function that I'm going to call after here. The idea is that you're going to give me a time delay along with a function. And then what this is going to do is it's going to sleep for a certain number of seconds, and then it's going to call the function. What's going to happen here is I could write a function like hello. I could pass that as an input to the after function. I could say, well, after 5 seconds, why don't you call the hello function? So it's going to sit there for 5 seconds of dead air, and then all of a sudden you see it fire. That wouldn't work if you couldn't pass functions around just like other pieces of data. Like in this function call, there's no difference between the 5 and the hello as far as Python is concerned. It's just you're passing in some data. You see this in various places in Python, like sorting, for instance. If I had like a list of names or something, maybe a list of names with like mixed case or something, you might see somebody doing something like this. Sort key equals lambda name, name.upper or something. What's happening there is you passed in a function. Since we haven't talked about it in a while, just refresh your memory that lambda is actually a shortcut in Python for making a function. Like I could say lambda x 10 times x, that creates a function where you give it an input and returns 10 times the input. So this is a very common thing to see, this idea of making functions, passing functions around and using those. Just as a note on the lambda, by the way, one use of that sometimes comes into play, we have this greeting function that required an argument. One problem with that is I wouldn't be able to use that using my after function. Like I couldn't say after 5 greeting because this func isn't called with the right signature. I mean, basically it's going to blow up saying, hey, where's the name? I could fix that by doing something like a lambda. Like I could say, well, here's a lambda function that's going to be greeting of Guido. What I've done is I've defined like a little function that takes no arguments, and it's going to do hello Guido. This is the first part, passing functions as arguments. Turns out that you can extend this idea in yet another direction and actually have code that makes functions. So what I'm going to do here is define a function add xy, and then inside that function, I'm going to write a little function doadd. I'll make it print. This is not the most interesting code. So I'm going to make it just print, saying it's adding those values, and then let's return them back. Turns out that you can have Python code where you make a function, and then you return the function back as a return result. From Python's point of view, there's no difference between doing this and returning like a 10 or hello or something. It's like what you did is you made some code, and you returned it back. If you were to call this function, like if you said a is equal to add 2, 3, it's going to come up and say, well, okay, you made this thing called doadd. It turns out that it will even work. Like if you say a, you'll see the function fire. Even though you made a function, you returned the function back. You didn't actually call the function, you returned the function. If you made another one of these, like, hello world, for instance, there's another function. It's like you have code that's like making functions. One kind of interesting thing about what's happening here is that this function that gets created captures the surrounding environment. One thing that's maybe a little bit disturbing about this actually concerns the X and the Y here. You will notice that this doAdd does not take an X and a Y. There is no X and Y. Well, actually, there is an X and Y there. Let me delete those. So now we don't have X and Y. You'll notice that these functions, they still work, even though there's no X and Y sitting around. The reason that they work is that they actually will capture those variables and kind of take them along with the function. That idea, by the way, is something known as a closure. So if you define an inner function, you get something known as a closure. An essential feature of a closure is that it will capture the variables that are needed, kind of carry those along with it. That might look kind of like an esoteric thing, but it turns out that this is actually a very commonly used part of Python, this idea of defining functions, carrying along information. One of the things that's going on with this add function is that I'm actually getting something known as delayed evaluation. When I say a is equal to add 2, 3, I'm not actually doing the add. I just made a function to do the add at some later point in time. Somebody might take that and they would say, well, okay, after 10 seconds, I want you to call this add function. What's happening is that made like a little piece of code. It went and got passed off somewhere else. And then after 10 seconds, you're going to see the thing fire. Oh, you're adding 2 and 3, you got 5. This is a programming pattern. It's actually quite common in things like distributed computing, thread programming, things like that, where you'll package up some work to run at some point in the future. And it's actually really important that you capture the environment. And again, you also see this with things like the sort function, taking that key argument, things like that. So this is a very useful feature of Python, this idea that you can make functions, pass them around, return functions. It also turns out that this is a really useful way to simplify code. And that's what we're going to look at in the next section.